Did you know household showering in the UK approximates the 2 billion litres of water waste across Britain? Our aim is to prevent this by encouraging healthy habits in young children. On that note, let me introduce myself. My name is Aruya. I'm the compliance officer and the electronics expert.
Hi, I'm Taryn and I'm the planning officer.
Hello, my name's Hudson and I'm the programmer.
Hi, my name is Gian and I am responsible for design and manufacturing.
Together we are FlowSense and we can't wait to present our Raspberry Pi-based project.
To summarise, our project uses a Raspberry Pi as well as a flow meter to transform shower water conservation into a lesson of financial competence for young children.
By syncing real-time data via Firebase to a companion app, the system automatically subtracts in-game credits when a child exceeds the shower limit. This is signalled by a flashing LED.
This creates a direct link between water waste and monetary loss, promoting eco-conscious habits at a young age.
On that note, let's move on to a live demonstration where we'll go into more depth while describing the ongoing processes.
Our project utilises the Raspberry Pi 5 as well as other key components such as flow meter and LEDs. It is powered using a portable charger and we have a listener script set up on Python. It constantly runs in the background, so when the switch is triggered, our main code can automatically run.
When water begins to flow through the flow meter, the Pi will count the number of rotations during the entirety of the shower. By taking data from our calibration test, it will automatically convert the number of rotations into the volume of water used. While this is occurring, the 10 LEDs will light up by using the calculated water volume. Citing the Energy Savings Trust, the recommended water volume to be used per 10-minute shower is 70 litres. We set each LED to light up after a tenth of this value had been used to give the user an indication of how much water had already been wasted.
Once the user exceeds their target water usage, the final green LED will begin to flash. This alerts the user that they have spent an excess amount of time in the shower.
Once the shower is complete, the Pi syncs the water volume data to the companion app using a real-time database called Firebase. This allows the app to automatically subtract a corresponding amount from the overall score. This could prevent the user from buying more expensive game avatars in the future, hence teaching them the value of money.
To go into more depth with the game itself, it was created using an online game engine called GDevelop. We created a basic endless runner game where the avatar must collect coins while dodging obstacles. We also created an in-game store where players can purchase different avatars depending on their balance. To connect this to the real-time database, we had to integrate a Firebase snippet within the game's properties. We also integrated the same snippet into our Python code. This allowed for seamless data transfer between two different parties, creating a connection which is integral to the function of our project.
If our product were to be assembled on a mass scale, here are a few things we would change.
We should compress breadboard to variable to make the project more compact. This will increase portability and maximize space utilization.
To make our product easier to install, we should use snap-on clips and a more appropriately sized flow meter.
Lastly, we would make the app more accessible by adding it to the App Store and Google Play, so children can use it as intended.
I hope you can see how our project can not only benefit the environment, but also the next generation financially.
This product will become a staple in the bathrooms of many homes across the UK. If young people only comply to using 70 litres of water per shower, it would be beneficial on a national scale, as it would reduce our carbon and water footprint.
Thank you for listening to our brief presentation and we do hope to hear back from you soon.